So, welcome everybody to my new channel Mathagrata. Here we are gonna explore the hidden patterns and mysteries and deep ideas of reality behind the concepts of mathematical and metaphysics realm. Our today's topic of discussion is palindromes. So, what is palindrome? As you can see in the screen, a palindrome is a word, phrase, verse, or sentence that reads the same forward or backward. For example, so here, see these words carefully. Here is a number 71849 and 817. You read it backwards, it would be yielding the same 71849 817. Or read this sentence, damn it, I am mad. And you read it backwards again, it would be DAM, damn, MIT, that is, damn it, I am mad. You read it backwards. You read the words like mom, rotator, or the number given here 02022 and also go backwards, you will yield the same mom, radar, rotator, and the number given here backwards as the same you read it forward. Some example, finest example is Malayalam and Katak. Whether you read it forward or backward, it would be pronounced and means the same. Many fun stuffs that we can do using this core concept of palindrome, that is taking whether that 1331 is the number is a palindromic number or not. We can find this by using programming C, and running the code we can verify if the number is 1331 is palindrome or not. Make similar type of prime palindromic pyramids, like you can see here the two columns like 211 101 10301, and here 711 929 98689. Finally, finding out a palindrome number using a random given number. As here we can see, the given number 754 is reversed 457 and added to get the number 1211, and it is reversed again, and 1121 is the yielded number, and adding them, summing of them, we get 2332. And after doing this operation, how we get the palindromic number 2332. So here are the fun facts and fun stuffs that we can do in mathematics using palindrome. And as there exists a famous equation which translates that into the summation of all the natural numbers till infinity, which is yielding a minus 1 by 12, and is called the famous Ramanujan paradox. So I have also tried to devise one of my own new equation that is known as Mathagrata's palindrome. It is falling upon the name of my channel, that is Mathagrata, and the equation is called Mathagrata's palindrome. So before diving into the Mathagrata's palindrome or pure mathematics, let's know some key facts about the prerequisite golden ratio phi. It is going to be the center of concept in our Mathagrata's palindrome equation. So what is phi? So if we take a line segment whose length is a plus b, and it is divided into two parts, a and b, then the golden ratio phi would be equals to a plus b by a, or a by b. Supposingly a is the longest part and b is the comparatively shortest part. And the golden ratio was also called the extreme and mean ratio by Euclid, and it is also called the divine proportion by Luca Pacioli. So let's know what is the golden ratio more in the customary world. Let's understand this golden ratio or phi in simple terms. So here is the beautiful monument, Roman monument, the beautiful sunflower, the beautiful pyramid, a beautiful woman, and the most beautiful painting in the world, Mona Lisa. Do you have ever imagined why these images are perceived to our eyes as appealing and our brain processes them as beautiful or attractive? This is because their facial or structural symmetry is very much nearing to the golden ratio of phi. If we divide their facial or structural symmetry into A and B and we measure it, their symmetry will be much nearing to the golden ratio of phi. And that's why when this ratio is exactly the same as the golden ratio of phi or nearing to that, it gives a beautiful combination of patterns or symmetry which our eyes appeal and our brain appeal naturally, and this is why we can say something as beautiful or not. As you can see, Mathagrata's palindrome bridges these frameworks. It uses the foundational geometry of the golden ratio phi to construct an infinite bidirectional series, while standard arithmetic implies that expanding outward into opposing infinities should lead to the unbounded divergent chaos. This identity proves that the past, that is up to the negative infinity, and the future, that is up to the positive infinity, acts as a structural mirrors. They collapse inward into the present moment, creating a perfectly closed finite geometric value. Hence, diving into the mathematical identity directly, the fundamental equation of the Mathagrata's palindrome states 1 by phi to the power mod n, where n extends from minus infinity to infinity, summed up equals to phi to the power 3. So what does this feel in the expanded form? To visualize the palindromic architecture of the sequence, we expand the summation manually. So when we expand it from 1 by phi to the power mod n, where n is a positive number, then it stands for 1 by phi plus 1 by phi square plus 1 by phi cube, etc. etc. And when we expand it with n is equal to negative number to minus infinity, we get 1 by phi to the power 1, 1 by phi to the power 2, 1 by phi to the power 3, till 1 by phi to the power infinite. And because any non-zero number raised to the power of 0 is 1, so we get 1 by phi to the power 0, which is equals to 1. It gets 1 by 1. So is the entity or the term 1 by phi to the power 0 is nothing but just 1. So here is what happening is that by substituting the values of n moving symmetrically away from 0 in both directions, we see the infinite mirror explicitly. So reading this infinite line from left to right yields the exact same sequence of the mathematical entities as reading it from right to left. You read it from 1 by infinity plus 1 by phi cube plus 1 by phi square plus 1 by phi to the power 1 plus 1 plus 1 by phi to the power 1 plus 1 by phi to the power 2 plus 1 by phi to the power 3 plus till 1 by phi to the power infinite. So it satisfies the definition of a structural palindrome across an infinite canvas. Now, directly before diving into the algebraic proof, we have to understand the three prerequisite unchanging axioms. It is from the Euclidean geometry and from the sequence analysis. So let's get into the first axiom, that is upon the independent discovery of the golden ratio phi. So, given by Euclid's elements 300 BC, it is known as the extreme and mean ratio. Suppose think of a line segment which is divided into two asymmetric parts. One, the A, which is the longer segment, and B, the shorter segment. So as we have discussed before, this fundamental axiom also. So let's quickly revise it. So here is the line segment divided into two asymmetrical path. One is A, the longer part, and other is B, the shorter segment. So the whole length of the line would be a plus b. So the axiom states that the ratio of the length of the total line, that is a plus b, to the longer segment, that is a, would be equal to the length of the longer segment a to the length of the shorter segment, that is b. So we can write it as the length of the total line a plus b by the length of the longer segment, that is a, equals to the length of the longer segment a by the length of the shorter segment b, that equals to phi, that equals to 1.618033 dot dot. I hope you can better understand now. So now, since we have a plus b by a equals to phi, we can write it further simplifying as a by a plus b by a equals to phi, which implies 1 plus 1 by a by b equals to phi. We can just simplify it using the laws of fraction. So now, substituting phi back into the fraction, we get 1 plus 1 by phi equals to phi. This is because we have a by b is also phi. So we can write it instead of a by b, the quantity phi as the denominator here in the equation. So the equation becomes 1 plus 1 by phi equals to phi. But now we want to eliminate the phi from the fractional denominator. So let's multiply it in the both side. That would be phi into 1 plus 1 by phi equals to phi into phi. That equals to phi plus 1 equals to phi square. Hence, we reach at the axiom A result equals to phi square equals to phi plus 1, which can be further rearranged into a quadratic equation, that is phi square minus pi minus 1 equals to 0. Let's understand the axiom B. So now first take phi q. So what would be the result of phi q? Phi q equals to phi dot phi square. We can absolutely write like this. And now we have phi square equals to pi plus 1. So putting it here, we get phi q equals to phi dot phi plus 1, which equals to, which implies phi q is equal to phi square plus phi. Now again we have phi plus 1, this phi plus 1 equals to phi square. So we can put here phi q equals to pi plus 1 plus pi. That we are putting the phi plus 1 instead of phi square here. So I hope you can understand. That is phi q equals to phi plus 1 plus pi, which would be equals to phi q equals to 2 phi plus 1. So here we can get high powers of the golden ratio and can continuously collapse down into simple linear combinations. So we get the results like phi square equals to pi plus 1. Then upon solving phi q, we get phi q equals to 2 pi plus 1, and we get phi to the power 4 equals to 3 pi plus 2, phi to the power 5 equals to 5 pi plus 3, and so on. You can solve it by solving yourselves. So starting from 1 by phi to the power infinite dot 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 plus 1 by phi to the power q plus 1 by phi to the power square plus 1 plus 1 by phi plus 1 by phi to the power square plus 1 by phi to the power q dot 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 plus 1 by phi to the power infinite. What is this? This is nothing but just an infinite geometric series with the common ratio r equals to 1 by phi, which is multiplied with every term to get the second term, and is multiplied with the second term to get the consequent term, that is the third term. And since here r, the scale factor or the common ratio, is less than 1, because r equals to nothing but 1 by phi. And what is the value of phi? It is 1.618. So r equals to 1 by phi equals to 1 by 1.618, which is less than 1. Hence, the summation of the series gives us the formula S is equal to A by 1 minus R. Here R is the common ratio and A is the first term. Now, let's jump into the absolute step-by-step proof. So, now we break the Mathagrata's palindrome into three distinct visual zones. The right side, that is the positive future infinity, the left side, that is the negative past infinity, and the center element, the present anchor. Let's isolate and solve the positive infinity vector. So we isolate the sequence moving forward the positive x-axis where n scales from 1 to infinity. So summation future s future equals to summation from n equals to 1 to infinity 1 by 5 to the power n equals to 1 by 5 plus 1 by 5 square plus 1 by 5 cube plus till 1 by 5 to the power infinite. So this is a standard infinite geometric series we can see. So from our axiom C, we have the opening term of the sequence, that is A equals to 1 by 5. 1 by 5 is the first term, and the multiplying ratio in terms of R is R equals to 1 by 5. That is 1 by 5 multiplied to each and every term here to get the consecutive term. So we insert these explicit terms directly into our convergence formula. So S future equals to 1 by 5, that is A, by 1 minus 1 by 5, that is 1 minus R. So what we get is that S future equals to A by 1 minus R equals to 1 by 5 by 1 minus 1 by 5. So now to eliminate the complex fractions, we must multiply the numerator and denominator by 5. So S future equals to 5 into 1 by 5 whole divided by 5 into 1 minus 1 by 5 bracket. So S future implies S future equals to 1 by 5 minus 1. So we can simplify the denominator using our original baseline from axiom A. So if we take the 5 square minus 5 minus 1 equals to 0 quadratic equation from axiom B and add 1 to both the sides, we get 5 square minus 5 equals to 1. So factoring out the 5 reverse 5 into 5 minus 1 equals to 1. Now divide both sides by 5 isolates our denominator precisely to 5 minus 1 equals to 1 by 5. Just bring the 5 to this side and we will get 1 by 5 equals to 5 minus 1. Or you can divide both the sides by 5. So now we substitute the equivalent back into the bottom of our calculations, that is S future equals to 1 by 5 minus 1. Here we can see S future equals to 1 by 5 minus 1, and instead of 5 minus 1 we put the 1 by 5 that we got here. So multiplying the reciprocal completes the calculation. We get S future equals to nothing but 5. I hope you can understand this. Now, since we are done with the positive infinity factor, now let's come and isolate and solve the negative infinity factor. So what was our initial summation? It was S equals to summation n raising from minus infinity to infinity 1 by 5 to the power mod n. It was the original one which we had from the initial proof. But since in the positive infinity factor n is positive, so we don't need to put any modulus. But since now we are dealing with the negative infinity factor, we have to write s past equals to summation n raising from minus 1 to minus infinity 1 by 5 to the power mod n. And we since know that the modulus converts any negative input to the positive one, then we can write s past equals to 1 by 5 to the power minus 1 mod plus 1 by 5 to the power minus 2 mod plus 1 by 5 to the power minus 3 mod plus dot 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 till 1 by 5 to the power minus infinity mod. that equals to the expansion is like this, that is 1 by 5 to the power 1 plus 1 by 5 to the power 2 plus 1 by 5 to the power 3 plus dot dot dot, because of the core absolute value operator of mod n. And here the final progression or the expanded progression we get is similar to the positive infinity vector. We have a equals to 1 by 5, the initial value, the common ratio 1 by 5, that is r. Here we can see 1 by 5 is multiplied to every other component or the every other term to get the consequent term, and 1 by pi is the initial term, just like the positive infinity vector. So we get our final solution is past equals to phi, which is exactly equal to the same result phi that we get in the by solving the positive infinity vector. I hope you can understand that how we get s past equals to phi, which is same as s future equals to phi in the positive infinity vector. And now coming to the last part of our proof, that is evaluating the central anchor, the single remaining point inside the bidirectional sum where the absolute origin where n equals to 0. So S center equals to 1 by 5 to the power mod 0 equals to 1 by 5 to the power 0. So now we know that 1 by 5 to the power 0 is nothing but just 1, because 5 to the power 0 is 1. So S center equals to 1. Finally, it is time for hitting the last nail in the coffin, or the last part of our proof, that is the complete resynthesis. So what was our original summation? It was summation n raising from minus infinite to infinite 1 by phi to the power mod n, that equals to s past plus s center plus s future, because we have divided our summation into three parts, and we get the value that summation n raising from minus infinite to infinite 1 by mod to the power n equals to phi, that is s past value, plus 1, that is s center value, plus phi, that is s future value, that equals to 2 phi plus 1. And as we know from axiom b, previously we got axiom b and c, that the value of 2 phi plus 1 is nothing but phi q. So we are getting the summation n equals to minus infinite to infinite 1 by mod n equals to phi q, and this completes the absolute proof. Hence, the infinite palindromic sequence resolves beautifully without any error or summation to a clean geometric cube of the golden ratio. I hope you must have all enjoyed this golden ratio palindromic sequence invented or discovered through an beautiful intuition and mathematical synthesis. So, this is what I have to bring out to you. I hope all of you have enjoyed it. And thank you. And have a nice day.